Hi, I'm Zach and I work at Yucatan. At Yucatan, we're making smart insoles. They have 16 pressure sensors, a motion sensor, and haptics. You can connect them via Bluetooth or Wi-Fi and receive pressure and motion data in real time, which can be used to calculate the wearer's balance, gait, foot orientation, and whatever else you'd like. Our insoles also support TensorFlow Lite, so they can even store custom machine learning models for detecting more complex features, like recognizing gestures such as kicks or estimating a user's weight. By partnering with Snap, we were able to connect our insoles to the spectacles via Bluetooth, enabling developers to integrate the insole's pressure and motion data into their lens. We got access to a special version of Lens Studio and Spectacles firmware that had a Bluetooth API, and we used that to create our own API for our insoles. So in Lens Studio, you can connect to our insoles by setting the name of the insole, whether it's a left or right insole, and what data you'd like to receive, and at what rate, like orientation data every 20 milliseconds, and pressure data every 100 milliseconds. Then you add a callback function that's called every time there's new data from the insoles. While Lens Studio already provides body tracking and even foot tracking, the camera has to be pointed at your body or down at your shoes, which limits the kind of experiences you can make. It also uses significant processing power, but with our insoles, you can receive a sufficient subset of that data, where you wouldn't get stuff like foot position relative to the camera like you could with foot tracking, but you can get foot orientation, which would allow the developer to point the lens at whatever subject they want to highlight, all while lowering the processing power by switching from an intensive task like continuous body tracking to a simple Bluetooth data stream. One lens we made that paired the spectacles with our insoles was an AR skating experience, where you skated through a forest of trees, leaned back and forward to change speed, leaned side to side to dodge trees and collect coins, and jumped on benches to grind for points. If you were to create a similar experience without our insoles, you could have the user tilt their head to turn, or swipe along the spectacles, and literally jump to jump, using the spectacle's vertical position to detect jumps, or just tap on the spectacles. When prototyping the lens, I just used touch and tap events for turning, accelerating, and jumping, which wasn't as immersive, but it was possible, though it wasn't as fun, but I may be a little biased. Working with the spectacles and the Snap team was a great experience, and there's plenty more ideas we can experiment with, like a yoga lens that displayed your balance as you performed each pose, using your center of balance to tilt a platform for physics-based puzzles, using step detection to generate sound effects, like the sound of stepping on crunchy leaves, walking on snow, or making tapestry sounds as you walked around. Maybe use a stationary bike with our insoles to detect RPM, cycling direction, and pressure applied, and make an AR racing game. Maybe a giant game of Jenga that shaked as you stepped around it, or a sneaking game where you have to step lightly on a creaky floor or you'll get caught. More health-oriented experiences could include warning you if you're leaning too much on one foot, or correcting your posture in real time, where these lenses could run in the background in endurance mode and come up and correct you through haptic feedback, voice, or even a lightweight heads-up display. While playing with the spectacles, we noticed that while it was great for displaying content, there wasn't much when it came to user input. You'd have to tap on the spectacles, speak, or put your hand in front of the camera, which blocked your view of the scene, had a limited range of actions, and got tiring after a while. Plus, you used significant processing power to track your hand. Ideally, you'd want something like a keyboard and mouse for inputting text and selecting objects that was in a wearable form where you can relax your hands on the table or down at your side. That's when we came across the TapStrap by Tap Systems, a wearable keyboard and mouse that you can connect to via Bluetooth. It detects finger taps and uses a custom key mapping that maps finger tap combinations to various keyboard characters and mouse actions. In the past, we made a web SDK for the TapStrap to experiment with, so we knew the Bluetooth interface pretty well. Combining that with what we learned integrating our insoles in the Lens Studio, we integrated the TapStrap in the Lens Studio as well, giving our lenses keyboard and mouse functionality. We even made a UI that used the TapStrap to navigate a tree-like menu for quick actions. We used this to create a piano lens that mapped the fingers to keys on a piano, where you could set the scale and everything, mapping your fingers to keys within that scale, and we even used our insoles as a sustain pedal. To connect to the TapStrap in Lens Studio, all you have to do is type in the TapStrap device name, select whether you're wearing it on your left or right hand, and choose if you'd like to receive mouse data in addition to tap data, because the mouse data comes at a really high data rate and can overheat the spectacles if you use the mouse a lot. While Lens Studio's built-in 3D hand tracking is great for immersive actions like grabbing and moving objects in a scene, I think a faster, indirect way of interacting with a scene can definitely be more useful, because with the TapStrap, I was able to manipulate objects, type, and navigate menus way faster than if I were to use 3D hand tracking, or my voice, or touching the spectacles. Plus, you can map a unique action to every possible finger tap combination, which there's 31. It can go even higher if you include double or triple taps. Plus, the TapStrap is like $70 for the original version, which gives you pretty much everything you need, and you can even use one for each hand. So you don't need to acquire a company for over $500 million to get that kind of functionality. In addition to our smart insoles, we also made a stripped down version that just contains the motion sensor. It comes in a little case with a hook design that allows us to attach it to virtually anything, like shoes for foot tracking, headphones to upgrade into a 3.5 headset for spatial audio, your wrist for stuff like detecting swings for virtual ping pong or tennis, or tracking reps for bicep curls in the gym. You can even put them all around your body for a low-cost cameraless body tracking solution. You can put them on a balance board for fun balance games. You can even make a Beat Saber-like experience by swinging your arms, and even include the insoles by stomping or kicking. You can even wear it on your back to detect slouching, and can even attach them to a prop steering wheel for turning. There's a lot of cool stuff you can do with them. In the past, we've made demos using our insoles in VR, but we've always wanted to do them in AR because it's the perfect feedback mechanism for insole data, because you can't just look at your phone to look at pressure data while you're running stuff. But we never really bothered with mobile AR because you're still holding the phone. Spectacles wasn't really on our radar, but someone from Snap reached out, and as we learned more about the spectacles, we realized it was a great companion to our insoles, and realized how great their development environment was for rapid prototyping. Plus, the team at Snap was really supportive, and I really appreciate the opportunity to get to work with something so cutting edge. Developing for the spectacles was pretty straightforward, since we already made a web SDK for our insoles and motion module. It wasn't exactly copy and paste, since Lens Studio uses ES5 JavaScript and their Bluetooth API wasn't based on web Bluetooth, but it's still pretty feasible. Debugging was kind of hard because you couldn't preview Bluetooth connections in Lens Studio, and I wasn't able to debug the spectacles over USB, so I had to rely on logging everything with AR text, which is hard because my vision is bad, and the text had to be really big and sometimes wouldn't fit. And if the lens crashed, I still wouldn't know exactly why. But the excitement of connecting our insoles to the spectacles was enough to endure all that. I don't really play with AR much because it's kind of boring, to be honest, just looking at stuff with little interaction. But after integrating the insoles and Tapstrap, it unlocked so many ideas. The lowest hanging fruit being the port all the Wii Fit-like games, and seeing what popular VR games can be ported like Beat Saber, and making real versions of those fake AR visualizations you see online of like a virtual desktop where you can edit documents and stuff, but now we can actually build it. The Spectacles has a lot of potential, and while it's limited in some areas like field of view and battery life, it's good enough for prototyping whatever ideas we have. Sometimes we'd have to scale back on what we wanted to do, but as long as we capture the essence of the experience, we can always go back and extend it as Snap improves their hardware and software. Like for instance, in the skating demo, we had a narrow field of view, so we added these barriers to the sides to create a focal point that kept the scene in frame. Also, the 10-second recording limit is kind of annoying. Plus, the piano demo wasn't able to capture audio in the recording, which kind of sucks, but I assure you, it really plays sounds. But in the end, it all works, which is insane. And it's so easy to get from an idea to a working prototype that I spend 99% of my time thinking about the experience itself and not dealing with technical issues, because it just works. Well, 99% of the time. Being able to debug over USB would be nice. The lenses I've made so far have all been successful, and I feel like we've just gotten started with what we can do with the combination of our insoles, motion modules, Tapstrap, and the spectacles. I think the biggest problem with AR is people use it to take information and put it around you, so you have to turn your head or get up and walk around. But it should instead take everything around you and put it in front of you, and frame everything in a digestible way. There's a lot AR has to offer, like using object recognition to log all the stuff we see around us, like a physical file system. So if I don't know where something is, but it was in front of my face at some point, I could say, "Where's my keys?" or type it in like Spotlight, and have an arrow pointing to where I last saw it. We can even make connected lenses so anyone else who saw it can share that information. Like if I handed my keys to a friend temporarily and maybe they left it in a drawer without telling me. It could even be anonymous, like if someone lost their cat, others in the street may have seen it at some point and can report it. Sort of like AirTags, but like implemented better. Object recognition could even be used to assist the visually impaired, where the spectacles can detect a bunch of objects in front of you and play spatialized sounds indicating what those objects are, like the sound of jiggling keys where your keys are to let you know what's there and where it is. You can even anchor a persistent sound to the object with parameters of that sound mapped to the object state, like mapping the temperature of an electric stove burner to the sound of fire that intensifies as the burner gets hot, alerting you that the burner is on and is hot, giving a voice to the invisible information around you through data sonification. You can also use sound recognition to detect actions like the click of turning off an oven burner or the sound of locking your front door, so you can make sure you did what you needed to do. That way it can log what you did and know what it's supposed to listen to as it learns your habits, reminding you that, say, you forgot to turn off your oven or lock the front door. We're just really behind with what we can do with audio, like data sonification and auditory displays in general. Sound is really underappreciated, especially spatialized audio in AR, because it's not limited by any field of view, and you can hear things behind you, but you can't see things behind you. And if you really think about it, the phone is the first AR headset, because calls are like audio holograms of other people. It would be really cool if Spectacles added eye tracking and could detect text in a scene, so it could know if you're reading something and know which word you're on. Then you can use text-to-speech that reads aloud the text as you read it, which can be useful for learning foreign languages, or reading sheet music, or for new forms of literature where pre-recorded voices can accompany dialogue in a story, along with an audio bed to set the scene, as well as sound effects that are triggered at certain parts in the text. Like, just a lot of cool stuff like that. I hope Snap continues to publicly iterate their tech, and I can't wait till it gets to a point where everyone's wearing them and using their lenses. I don't see them as having a specific use case, like a killer lens, but instead having these seamless micro experiences that come in and out as you need them, like walking into a store and opening the store's lens, where you can see where the items you usually buy are and what reviews they have, and maybe even like show the prices of frequent items you buy displayed outside the store, like gas prices at gas stations, or walk by a restaurant and listen to reviews converted to speech and spatialize inside that restaurant so it sounds like customers are saying those things. You can even set filters on what kind of lens you want to open at a time, like, if you're hungry and you want to eat something, you can enable the restaurant review lens. Or if you're looking for a job, you can enable an employment lens, where if you walk past someone from a company you want to work for, it'll alert both of you that you're looking for work, they're looking to hire, and you have a relevant work experience, turning the physical space into a single social network. Every day we pass by so many people on the street not knowing who they are, when they could be exactly who we've been looking for whatever purpose. Like, maybe you're trying to sell your bike, and they're looking for a bike, but you never know. People pay thousands of dollars in rent to live in some areas because of the people, but we don't take advantage of that, relying on all these meetup apps and expensive conferences where you probably talk to like one person and go home. But we can catalyze all that by having a way to list what you're looking for and choosing when you want to activate these alerts. So you can go on a walk, meet an employer, find someone to buy your bike, see a cat that went missing an hour ago and alert whoever lost it by logging the location, all on your way to the grocery store to get some eggs. We need this kind of social area network, not a bunch of separate apps made up of the same people wearing different outfits in their profile pictures. I think the most exciting feature of the Spectacles is that they work. They just work. And they work now. And all the ideas I've written down over the years of, oh, that'd be a cool idea someday, is now possible. And I can easily break it down into actionable steps in Lens Studio, and whatever I can't do right away could probably be done if I gave Snap a call. The Spectacles didn't necessarily change my creative process. It processes my creativity. It can interpret it and run it, like literally. I think what makes experiences on the Spectacles so special compared to the phone is that with the phone, it feels like the content comes from the phone, and if you put the phone away, the content's gone. But with the Spectacles, the content comes from the area itself, and when you put away the Spectacles, you feel like the content's still there. It's just invisible, as if putting on the Spectacles reveals the content, like those thermal cameras. Viewing it that way, you don't open and close lenses like you do apps, but you show and hide these AR scenes that are anchored to some geolocation like restaurant menus, or attached to a physical object like a rep counter lens bound to some workout machine at the gym. It'll be interesting to see how our understanding of where we think the app lies as it transitions from being something inside our phone or on some server to something that emanates from the thing the lens is about.